Guys. All right, last week we talked about solving what? Just talk to you just a second. Last week we talked about solving by graphing, okay? When we solved by graphing, we graphed both lines and we found what? What did we find when we graphed both lines? How did we solve it? The coordinates of what? What part? Where they connect, where they intersect. So this would be the solution, right? When we graph both of them. So today we're not going to graph. We're going to still have two equations just like we had before, but we're going to solve them algebraically. Okay, we're going to solve them without graphing. So we're going to have these two things, two equations. Let's say y equals 3x plus 2. And let's say x, actually I'm going to go to a new page to do this. You don't have to. I'm just going to a new page. All right, 3x plus 2 and x plus 2y equals 11. So if I gave you these two equations and I said, find the x and the y that makes them both true, I'm going to assume you'd have no idea what to do, right?
Yeah.
Okay.
And you go up to oh yeah.
Without graphing.
I mean,
without graphing. All right, look.
Without graphing.
I want you to notice something. Look at the first equation. They're both different, right? They're different forms. Do you see that? The first one is in y equals, right?
Yeah.
It tells me what y equals. It says if you have a y, then the y has got to equal 3x plus 2. Okay? This is called substitution because what we're going to do is we're going to take one equation that's already solved for one variable. Okay? And we're going to use that to plug in to the second equation. Okay?
Oh, when you figure out the first one, you gotta plug it in with the x plus
okay? Now, watch. Because once we do this, it's going to look just like what we've done before. All right? So stay with me. If y equals 3x plus 2, right? Then I can take this second equation and I can say, well, if y is 3x plus 2, then I'm just going to replace this y with 3x plus 2. Because that y equals 3x plus 2. Okay. Y and 3x plus 2 are the same thing.
Why would you put all of that right there?
Because I don't know, if an equation has two variables in it, I don't know how to solve it.
So what you put for that?
But if I can just get one variable, so now I just have x's in here, then I can solve it.
What? So you don't put enough for that?
Not yet. We're going to solve it. All right. So my first step in this is to make one. That's a 2.
I see the jump say 3x plus 2, right? Wait, hold on.
And I'm just putting you some steps over here because sometimes that helps y'all to have it. So my first step is to look at the two equations and get one of them to have one variable by itself. In this case, it was already done for me with this first equation. It doesn't matter which variable you get by itself, whichever one's easier to get by itself, okay? So one equation, get the variable by itself. Once you do that, you're going to use that to plug in to the other equation. So you're going to use one equation to solve the other equation. All right, so that's all. We've done steps 1 and 2, but we haven't finished solving. So after you plug into the other equation, you're going to solve for that variable. So look at the equation in white. Distribute. I'm going to distribute first, right? We've done many equations like this in here. Okay, so I have x plus 6x plus 4. Now what?
Don't you say subtract 4?
Yeah, okay, you can, or you can, I would combine like terms first. So x and 1x plus 6x is what? 7x, that's right. Alright, so I've combined the two x's. Several of you have gone ahead of me and solved it. Now what do you do? Minus 4 on both sides. So I have 7x equals 7.
Divide 7x by 1. And it gets 8x equals 1.
Okay, so a lot of you went ahead of me and you said, Miss McGee, I got 1. Is that right? Is that right? That is absolutely right. Okay, now remember, when we were graphing lines, okay, when we were solving by graphing, our answer was a point. And a point has an x and a y. So I'm missing the y, right? So now what I have to do, can y'all let me talk?
I think the time broke too, because it ain't even 10 o'clock yet. I mean, 9:55.
We're going to take this value, okay, and we're going to substitute, or plug in is what I should say. Plug in this value to the equation from step 1. And we're going to do this so that we can solve for the other variable. Okay, so that very first equation that we had, the pen was messed up. That very first equation we had was y equals 3x plus 2.
What is it, right? Solve for other variables.
Right? Y equals 3x plus 2. So what we're going to do is we're going to take the x equals 1.
We plug in x for all the same.
And we're going to plug it in for the x in this equation. So we get y equals 3 times 1 plus 2. This is, oh, I'm hitting record. Shh, shh, shh. Let's look at this one. This one's a little bit more difficult than the first one, only because there is not a variable by itself here. So I want you to look at it, and I want you to think about something as you look at it, because my first step is one of these equations has to have a variable all by itself. Okay? Which equation is the easiest to get a variable all by itself? Well, if you did that one, I would have to subtract one of these two, and then I would have to divide. I don't want to divide if I don't have to. Shh. The first one is probably easier. Okay, look at this one. If x minus 2y equals negative 6, x is almost by itself now. Do you agree?
Yeah.
Okay, there's no coefficient in front of it. So what can I move, or what can I do to get x all by itself? Add 2y. All right, look what I have now. I have x equals negative 6 plus 2y. Yeah, but we're not graphing right now, so don't worry about anything with slope or anything like that. So now look, that was step 1. Get one of the equations, get the variable by itself. So now I need to use this and go to the second equation. Okay, the second equation is 4x plus 6y equals 4. And instead of x, what am I going to put in its place? What does x equal? This is going to go in the place of x. Okay, the x is going to go away.
I don't got it. Look at me either.
All right. This says that x equals, this says that anywhere you see an x, you can replace it with negative 6 plus 2y.
What is the most one that you don't say a y?
then any y could be replaced with that. Whatever variable it equals, that's the one you're going to replace.
Oh, okay then.
Everything else stays the same.
Okay.
Yes?
I know how to do
Now I distribute. What's 4 times negative 6? Negative what? 24?
Oh, see, I was about to say that.
And what's 4 times 2y?
8y.
8y. The plus 6y is still here equals 4. Now this is the part where y'all ought to fly through like pros because this is solving the equation.
Yeah, we combine the thing.
Combine the like terms, yeah. Combine the like terms, so 8y and 6y.
What I miss?
And how do you solve it now? Add 24, guys. You have got to stay with me and stay focused or you will not get this. So if 14y equals 28, what do I do?
Divide by 14.
Divide it by, is that the answer?
No.
No, you gotta figure out why.
That's half of the answer.
Yeah, plug in now.
Okay.
You gotta look at
So now, let me tell you this. I know that y equals 2, right? And I need x. Now, you could plug, the question is where do you plug in? I've got 1, 2, 3 different equations.
You plug it in
Plus 2y.
Any of them will work, okay? You could plug into any of those 3 and it would work. The easiest one to plug in though,
Actually,
Is-
negative 6 plus
yes, the one that you got x equals, because that's what you're trying to find is what x equals, right? So we know y equals 2, and we know that x equals negative 6 plus 2y. So if we plug in this one that we found here, then we can find x. X, come on. It's thinking about it.
10.
It's frozen a minute. It is. No, it's not.
It's negative 2. It's
4 plus negative 6 equals negative 2.
oh.
X equals negative 2.
I'm glad. I'm in something.
If we plug in,
Yeah, no, I'm just you.
Use the equation that we had got from.
yep.
Negative 6 plus 4 plus 5 is 4. Negative 2.
If I were to graph these, I would find that they intersect at the point negative 2, 2. You got a question?
Do we have to graph this one?
No. We will have, some of yours will be graphing and some of them will be algebraically. This is algebraically. All right, let's do another. Let's say y equals 2x plus 5 and 3x plus y equals 10.
Wait, let's see. What about elimination?
We're not doing that today.
We're not doing that?
I don't
Okay,
like tenses.
okay, y equals
All right.
2x plus 5. Plug it in for y.
It's what?
It's going to be 3x plus
10 or what?
2x plus 5.
Guys. Look at the first equation.
I figured it out.
It's already solved for you.
Yeah.
Y is already by itself. Can y'all see that color?
Yeah.
Yeah.
Okay. So step 1 in this case is done for us, which makes life easier, right?
Yeah.
Guys. So now, where do we plug this in? Where the y's at in the other equation, right? You always have to go to the other equation. So the other equation is 3x plus y equals 10.
That's a back.
Is it? Okay. So instead of y here, I'm going to put 2x plus 5. Okay, so I have 3x plus
2x plus 5. Add the like terms is equal to 5x. Then you're going to put minus 5.
That's right. Like terms, 2x and 3x would give me the 5x.
Divide 5x by 5, and that's equals 1. X equals 1.
There is a lot here. Before you divide, I have to move the 5 because I got to get the x by itself. So I'm going to subtract. And then divide. You're absolutely right. Now, that is only half my answer. Because I also need what?
The y.
The y value. So to get the y value, which equation is the best one to use?
Y equals 2x plus 5.
Because it tells you what y equals, okay? So what I'm going to do is I'm going to plug in the 1 for x, because that's what I know x equals. That's okay, you were almost there.